section 4.4 is going to continue this idea of proving triangles are congruent, which we explored some new kind of shortcut postulates yesterday. Let's recap on that. What do you think? What do you remember?
I remember that a while ago a couple days ago we talked about you needed 6 things to prove triangles congruent. All the sides and all the angles corresponding parts congruent. Where yesterday we did some shortcuts and we said, okay, side, 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 which was just the 3 sides, no angles. If we knew those 3 sides of one triangle were congruent to their corresponding sides of the other triangle, those 2 triangles were congruent.
Okay.
The other thing I remember we learned was side angle side, which was 2 sides with the included angle. And we used that word to say that it had to be between those 2. The angle had to be between those 2 sides. 2 sides in an included angle of one triangle were congruent to their corresponding sides and included angle of the other triangle. Those triangles were congruent.
Okay, so basically what I'm kind of hearing is one thing about it is that instead of proving 6, you're having 3.
Exactly.
And depending on what 3 pieces, we had side, 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 angle, side. We're going to learn 2 more ways of shortcuts, which is nice.
Good, we love these.
So let's get excited here. So we have, by the title, ASA and AAS. Notice they have, both of them have 2 A's and an S, which means they're both going to probably be dealing with,
I'm guessing angles and sides.
Yeah.
So is the first one angle side angle, and the next one is angle angle side?
You're exactly right. So let's talk about them. So angle side angle, which is the first one, or short, ASA. So think about specifically how that sounds. Okay, so you have 2 angles and the included side. So remember what Mrs. Hochgravy just mentioned for side angle side, that angle was included between the 2 sides. So if you're having included side, that means this side is between what?
Between the 2 angles in this case.
Good. So if you have that, they're congruent to 2 angles and included side of the second triangle. Well, guess what? Proving congruent triangles. All right, does that make sense?
Sure. So in that picture that I'm seeing below, we know that angle A is congruent to angle J. And we know that segment AB was congruent to segment JL. And we knew that angle B was congruent to angle L. So I'm seeing 2 angles with the included side. So now I can say that triangle, let's call it AGB, is congruent to triangle. I'm going to call that JHL.
So like she said, here's your angle, here's your side, here's your angle. So this side is included. Notice it's between the 2 angles. That's important because the next one, you want to take a guess what AAS stands for?
Angle, angle, side.
So that it has the same kind of information, right? It's going to have 2 angles and a side, but notice, let me go ahead and just show you. Notice what it's going to say differently. So angle, angle, side, or AAS for short, 2 angles and the non-included side.
Okay, so the order is what's changing.
The order is going to change. Are congruent to 2 angles and a non-included side of the second triangle, then of course the 2 triangles are congruent. So take a look at the picture.
So I'm seeing that angle A was congruent to angle W because those both had the 1 tick mark.
Okay.
And it's not an included side, so I'm going to go to the next angle. Angle X is congruent to angle B. And segment VX is congruent to segment BC. Okay, so yeah, I see it. It's 2 angles, but the side is not the side that's between those 2 angles. It's outside.
So this is your angle, angle, side idea.
Okay,
Good.
so then we know, let's name it triangle AXV is congruent to triangle WBC.
Okay, now one other thing that this is one where you could have some variation for your side. Okay, so let's see what I'm talking about. So if you're talking about angle, side relationship, the side has to be non-included. We use this side, these sides. So what if these weren't the ones? What other side could be the non-included side?
Non-included. Okay, so like AV and WC.
So you could have been given that and still been able to prove by angle, side.
Okay, so there's 2 different ways I could do these if they're angle, side.
And so the one side that you wouldn't want for this particular reason is the included side, which is these right here. So we can't say this is by angle angle side because it's angle side angle then.
That makes sense.
Okay, so there's a little bit differences, and it just depends on what you're given. Bottom line, you may be able to prove this information, but you may not. So you just have to understand which theorem you're going to use.
Okay.
All right, let's try some examples.
Okay, so for this first example, kind of sounds like what we did the other day. Is it possible to prove the triangles are congruent? Is it possible? We don't know yet.
Okay.
If so, we're going to give the congruent statement and the postulate or theorem that we're going to use. So take a look at these triangles, and what do you notice about them? What are some things that you see already?
Okay, I'm just going to brainstorm what I already know.
Okay.
So I already know that I have segment EF is congruent to segment HJ, and I also have angle E is congruent to angle J. So that's given to us already. We already know that.
Now, guys, if you were doing this on an assignment and you were trying to figure out if these could be proven congruent, you don't need to relist the given information. And I know we've said that before. But I'm just listing it so we see it right now.
In a proof, you will, but on a problem like this, like Ms. Hoker said. Exactly. Okay. So I'm just thinking out loud here. I have a side and an angle. So I have my reasons. I have side, 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 angle, side. Now I have angle, side, angle, and angle, angle, side. So I have a side and an angle. So that kind of eliminates side, side, side. So I either need another side or another angle, and depending on which angle, too.
Right.
So if I go with side, angle, side, I would have to know segment EG is congruent to segment EG is congruent to segment GJ. But do I know that? No, I can't say that. I can't assume, and I'm not going to assume that. So don't know that, so scratch that idea. So this is something, guys, this is something you can do. You can kind of like go through it if you don't see it right away. Angle side angle would mean I need an angle that includes that side. So angle F, I would need to know an angle H. And unless I was given those segments EF and HJ were parallel, I can't really say that. So scratch that idea. So really, if these are possible, this is the only reason I could say. So let me look. Angle, angle, side. I would need angle EGF. Ooh. And angle HGJ. Those are congruent.
Why do you know those are congruent?
Because of vertical angle theorem.
Perfect.
Okay, and again, guys, these may not be congruent triangles, so we can't just say, well, this is going to be congruent. We know for a fact they are because of vertical angle theorem.
And I love that you didn't just name them angle G and angle G, because we know that there are multiple segments coming off of that. There's not just one clear angle. So make sure you name it by all three letters. Okay?
Why don't you label those angles for me so I can, because I know where you're going next. I know what you're going to ask me.
Okay, what am I going to ask you?
You're going to ask me to give me the congruent statement.
Yes.
And knowing the label, and notice how she labeled it 2 tick marks. I love that you did that, because if you do 1 tick mark, then you're saying all of those angles labeled are congruent. And this will help you kind of decipher between what order you're going to go. Okay, so I'm going to name the first triangle EGF. So I'm going to go in order with the next one and start with J, because I've started with 1 tick mark, then go to G, and then go to H. And it's because you said postulate theorem, it's going to be angle, angle, side. I already knew that.
Awesome.
Okay. So same directions. Is it possible to prove these are congruent? And then if it is, then you're going to give me some more stuff. If it's not, then that's it.
Okay.
All right, so talk to me about it.
All right, I already know, and I'm going to just list my given information already. I know that angle I is congruent to angle P, and I know that angle K is congruent to angle Z. Again, that's my given information. I just wanted to make sure I see that. So right now I've got 2 angles. Okay, so if we go through and we start listing some of our reasons, we had side angle, side, 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 angle, side, angle, side, angle, and angle, angle, side. Now, I already have 2 angles, so I know it's not going to be side, 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 or side, angle, side. So I know I need a side. It's just a matter of where it's located.
Okay.
Okay. I'm looking at, let's see.
What if you were looking at this one?
Okay. Well, I'm noticing something here.
Okay, talk to me.
Well, if I want to talk about sides being congruent, I would either need to know that X would be a midpoint of a segment, which they don't tell me that.
Know.
Or I would have to talk about maybe like KI and PZ being congruent.
Do we know that?
Well, we don't know that.
Okay.
But we know that they're parallel.
Okay.
Because I see that, like if I talked about the alternate interior angle theorem converse would tell me that those are parallel, but parallel still doesn't mean that they're congruent.
Yeah, good.
Okay, so I'm looking at this picture. I don't see that those segments could possibly be considered congruent with what I'm given. I don't have any midpoints, so that's as far. I just can't do anything more than that.
Now,
I could actually talk about those third angles, the vertical angles being congruent.
But is that going to help?
But I haven't learned an angle theorem, so I'm going to say that it's not possible.
And we're going to talk about, we'll probably do this someday soon, and talk about the fact that there is actually no angle. All right, mainly because of the fact that it's just talking about all the angles are congruent. You could have an enlarged triangle, right? For example, let me just show you here. I'm going to pull up a triangle here. Let me just take this one. If I have that triangle and I just enlarge it, notice the angles aren't changing the size. It's just the sides are. So that doesn't prove congruent triangles at all.
Okay. Also, guys, another just kind of, we talked about, we don't use bad words in math.
Yeah.
Also, I always tell my students that AAA is very helpful when you have an automobile that's breaking down. But it is not very helpful when you are trying to prove triangles congruent. So those are the two reasons you're not going to see.
And I like how Ms. Hooker started. She narrowed it down to these only options, and she knew we needed a side. And there was just not enough information to prove it. Now, that's not saying they aren't. We just don't have enough information.
Okay. Let's take a look at a proof with this. So we've got some things in our proof. We see two triangles, and we know that we're trying to prove those two triangles are congruent. And I'm going to go ahead and start listing my given. And Mrs. Palermo, if you want to kind of just start thinking through this problem while we're...
So based on what she's writing down, I see some angles that are congruent, and I actually see two sets. So that I already know that narrows down some of my reasons. And since we're proving congruent triangles, we already know they are. That means we're going to either have angle side or angle side angle as my reasons. Okay?
Let's
label them. Yeah,
so
label
B
those
and
angles.
C. And we also said D
and F. Okay, the other thing I'm noticing is that M is given as a midpoint of segment DF. So we know some stuff about midpoints, and that's what I'm going to just start by saying.
Okay.
So I'm just going to say segment DM is congruent to segment FM. And my reason for that is definition of midpoint. And if you label it, you should be able to see what's going to happen.
And guys, again, it's a proof, so we know the triangles are congruent. It's just a matter of thinking about which theorem we're going to be, or postulate.
And if you go back to the given, I already had two pieces, two angles, and then I have a side. Now, does that mean it's angle, side? Well, look at the arrangement in the picture, and that's why labeling is important. I have an angle, I have another angle, and then a side.
And it's non-included.
Non-included. So I can say triangle BDM is congruent to triangle CFM. They're telling you what should be true, and the reason is angle, side. And like she said, non-included. I like that.
Yes.
All right, let's try another one, and I'll get the given kind of set up.
All right. Now, on this one, we're told that segment AD is congruent to segment CB, and we're also given some parallels. In fact, the same segments that are congruent are also parallel. And just by thinking back to last chapter, when we start to see those parallels, we know that there's going to be some special angle, or we're thinking, hopefully, that there might be some special angle pairs. And then we're trying to prove these two triangles congruent. So we already have one side that's congruent. So that's kind of nice. We're totally up in the air. The only thing, well, it could be anything right now.
Yeah.
We know that if we're talking about angles, we're probably not thinking side, but I'm just going to, it's still an option
what gives it away again, what she was saying, is that parallel. That parallel is probably going to tell you something about some angles.
Okay, so as I look at this, I know that there are some alternate interior angles that are definitely going to be congruent because I've got some parallels. And I'm looking at angle ADB and angle DBC. And I know that those are the angles that I want to talk about being congruent because I noticed that they go from the parallel to that transversal.
So if you kind of redraw, just to kind of give you a visual, this is what she's talking about.
Yes. So if you look, if I was trying to talk about angle maybe BDC coming along that outside, that angle right there does not go all the way up to the parallel line. So I know that that's not an alternate interior angle I can talk about. But I can talk about angle ADB is congruent to DBC.
Sorry.
It's okay.
ADB is congruent to triangle DBC. All right.
And that's because of alternate interior angle theorem. Okay, now I'm looking at those two lines of the parallels of the transversal that you drew, and those are the only alternate interior angles that we have. So going back to my picture, I know that these triangles are congruent. It's just a matter of how do I prove that then? Because that's all the angles. So if that's the only other angle I know, I'm going to start looking for another side. Okay. Oh, I see one more thing. They overlap. They have a common part.
Yes.
So I shouldn't say overlap. They share a side. So I noticed that DB is congruent to itself. And that reason would be the reflexive property.
Now, what if you said that before step 2? Like if you noticed that before your alternate interior angles, could you have done that?
Definitely.
Yeah.
Yeah, they don't depend on one another. So
Good.
The order of those two would
Good.
be okay.
And guys, sometimes that might help you. If you had noticed these sides were congruent first, or DB was congruent, then that would narrow it down that you would have to have the included angle if you were using the parallel. Often and Ms. Hograby mentioned this, often what I see, and I know she sees, a lot of people want to say these two angles are congruent, but that depends on these lines being the parallel, which they didn't give you that. Okay, those are not alternate interior angles of the lines that we were given parallel, like what Mrs. Hograby was saying. Yeah. All right.
Okay, so I'm looking at what I've got in my proof, and I realize I've got two segments and an angle that are already marked congruent. And when I look at my picture, I'm realizing it's two segments with the included angle.
Yeah, so the side
angle
side.
So I'm going to go ahead and make that statement that I've got triangle ABD is congruent to triangle CDB, and that reason is side angle side. And it is that included angle, so that's why I know I can use that.
Good. Excellent work.
All right. For our next one, notice we've got several triangles here, but look at what we're trying to prove congruent. GOJ and KMH. So make sure we're not looking at that little bitty triangle. It wouldn't be congruent to any of those. Okay.
All right, so she's going to write down what we're given, and I'm going to take a look at the picture, and I right away already see something that I'm going to have to worry about. The first part of the given says GH is congruent to segment KJ. And the reason why I say that's probably an issue is because GH and KJ, those segments, are not actually sides of the two triangles we're proving congruent. They're parts of the side.
Yes.
So that's going to tell us something. So we'll talk about that in just a minute. I also know segment HM, so that whole segment, I like how she labeled that, is congruent to segment JO. And then segment GO is congruent to segment KM. Now, something that you could do, because those triangles kind of overlap, you could redraw the two triangles, so that way you can kind of see what information that you have. And I know the common mistake, and while she's doing that, I'm just going to talk. The common mistake sometimes with this one is that you look at the given and you're like, hey, I have 3 congruent pieces. So I can go ahead and say these triangles are congruent because of side, side, side. Not happening, okay? If you look at what she's labeling, all right, there's only part of the side that's congruent. And if you want to label that little that letter, yeah, H, and then that's a J. Yeah, okay. So you have 2 sides, but we don't technically have that third side, right? Okay? So that means I probably need to prove somehow that GJ is congruent to HK.
Okay.
And I can. I'm going to look at the original picture too. And I notice in the original picture, GJ and HK overlap. We've seen this before in chapter 2.
Uh-huh.
So what I probably need to do is establish something about GJ in my particular proof. So all I can say is that GJ is equal to GH plus HJ. I hate using J's and G's.
I know, me too.
It makes me confused. And then I need to establish something about HK. So I'm going to say HK is equal to HJ plus JK. And that's because of segment addition postulate. And I used it in the same step. Hopefully you remember this.
Yeah, so adding two adjacent segments together, collinear adjacent segments together to form that larger segment. Perfect.
Okay. So I already see another issue. I've stated stuff about congruent, and now I've stated stuff about equality. So I'm going to have to do a little switching around. And I can't switch step 2 into congruence because I can't talk about measures being added together to be congruent. So I'm going to change... I'm
Do I
going
need
to go...
to change all of them?
No, because the 2 that we already know, the last 2, those are good to go. We're really only messing with that first one because that was the one I was questioning. So I'm going to change that to equality. So GH is equal to KJ. And that's because of definition of congruence. You could, if you wanted to, change all of it to equality, but what's the point?
Not needed, yeah.
The only reason why I want to do that, now take a notice of what I'm going to try to do. My goal is to try to get GJ and HK to equal each other. And right now, their sums are not exactly the same. So I want them to look the same. So I'm going to substitute, let's put KJ in for GH right above it. So it's going to be GJ equals KJ plus HJ. And I just substituted. Okay, so let's backtrack. So I've used the first part of the given, technically, and I've used step 2, and I used step 3. Well, I've used part of step 2, I should say.
Yeah, we still have this.
This. Okay, so I'm looking at it. I notice HK and GJ are exactly the same. They have the same sum. I know it's written differently. Do you see what I'm talking about?
Right. So here we have KJ. Here we have JK.
Same segment, right?
Same segment.
So the fact that they equal the same sum, they're equal to the same thing, I can say GJ is equal to HK. Now, I'm thinking since they equal the same thing, I could say transitive. I could also say substitution because I could just replace HK in for that sum.
Sure, you could.
All right. Now I've said they're equal. That's what I wanted to get to, but to prove congruent triangles, I need to say they're congruent. So I can just say, well, now GJ segment is congruent to HK segment. And that's because of definition of congruence.
Perfect. So am I done?
No, because I still have to say that they're congruent triangles. Do I have congruent triangles? I already had 2 sides. Now I have my third side right there. And you can even go to the picture. This is congruent to that. Okay?
I really would put 4, but I don't think I have room.
All right. So now I can say triangle GOJ is congruent to triangle KMH. And that's because of side, side, side. So this one's tricky because you'd think right away you have all 3 sides, but you don't just because you were given that.
Right.
All right, last one. Last one. Let me write the given. You start maybe brainstorming, sharing some ideas.
I am looking at this, and I have a set of segments that are congruent, and then I have 2 sets of segments that are perpendicular. And when I see those perpendiculars, I know that perpendiculars form right angles. And all right angles are congruent. So that may give me another set of angles. Tell you what, let's go ahead and let's start with that.
All right, so let me label that, and then so
AB and BC are perpendicular.
Okay.
So if those are perpendicular, that means that angle ABC is a right angle.
Okay, so I'm going to label that, and I'm going to write it down.
And I also know that PC and BC were perpendicular. And since I know that they form a right angle.
Okay, so what's going to be a right angle?
Angle PCB.
Oops.
And so looking at that picture, if they're both right angles, all right angles are congruent. I probably need to state that because I don't have a congruent statement.
Okay.
Yet. Oh, by the way, my reason.
That's all
First
right.
step 2 was definition of perpendicular.
All right, I'm going to backtrack just to make sure because, a lot of times when you get going, I do the same thing. I kind of think about, okay, where am I going? And she said some really good things. I want to make sure I restate because I think this is really good stuff. She stated these are right angles. that doesn't mean that we've stated they're congruent. So we still got to keep that in mind, okay? Also, something I did not say yet is remember where you're going. Do you see how there's multiple triangles in this picture?
Yeah, there really are.
And so the fact that we're dealing with triangle ABC, it might even help to kind of redraw those triangles. Ms. Hochraby did a great job that last picture of doing that. I'm going to do that just because I think it helps some people see a visual. Not everybody needs to do that. So you can kind of see these are the triangles you're talking about, and I'm going to go ahead and label. Now be careful when you're naming the angles. So in these pictures, you could name it angle B and angle C, but in the original picture, you need to name it based on the three. Okay, all right.
All right, so I'm looking at that, and I said, okay, because I know they're both right angles, I know that all right angles are congruent. So I'm going to say angle ABC is congruent to angle PCB, and that's my right angle congruence theorem that just says all right angles are congruent. Now, if you forget that right angle congruence theorem, keep in mind, you could have said they both equaled 90 by definition of right angle, then they were equal to each other by either substitution or transitive, and then turn it into congruence. It's just a lot of extra steps if we know that right angle congruence theorem.
So these are congruent. Good deal.
Okay. Now, looking at those, and you can look at either the separated picture or the one where they're put together, and you're going to realize they have a segment that's in common on both of those. Segment BC is segment BC on both of them.
Notice they share that side.
They share that common side. So I know that segment BC is congruent to segment BC, and that's the reflexive property.
So we label in the original as well so you can see it.
Which right now I see I've got, in my given I had a set of segments that were congruent. I've already used the perpendiculars to make my new statements. I've already used the right angles to make my new congruent statement. I've got a set of angles that are congruent and another set of segments that are congruent. So I've got three things that are congruent within these triangles. And as I look at them, I notice that it's two sides and it's the included angle. So I can go ahead and say that triangle ABC is congruent to triangle PCB, and my reason is going to be side, angle, side.
Good. And again, I want to say something just because I know this happens a lot. Be careful when you're naming angles, guys. All right? A lot of people want to say angle B and angle C, and I get what you're thinking, but there are too many angles that share that vertex. That's one of the most missed questions on this, I would say. Yeah. The other thing is that people want to just immediately say because they're perpendicular, they're going to be congruent angles. You can't go straight to that. All right? There's no reason for it.
Perpendicular does not talk about the angle itself.
Exactly.
We need to clarify that first.
All right.